Hello, everybody, and welcome to our next unit in grade 10 math. Today we are learning about the midpoint of a line segment. Okay, so before we get started, let's remind ourselves about averages, okay? So how do you determine the average? Well, let's say if you have two numbers, 3 and 5. That is way too thick. I'm using a new program, isn't it fancy? Anyways, how do you determine the average between them? Well, we know that the midpoint, the average between them is 4 because 4 is right in the middle. But remember that the method of doing that is by adding them together and then dividing by 2. So 3 plus 5 is 8. So the average between them is 4. So what about the average between -1 and 7? Well, we can think, okay, these numbers are 8 apart from each other. So the midpoint will be 4 away from each of them, so 3. But again, the formula for average is you just take the two numbers and add them together and then divide by 2. You're just taking the average. So that's 6 over 2, which is 3, which confirmed what we were saying. But what about the midpoint of a line segment? If you know the two coordinates on either end of a line segment, how do you know what the midpoint would be? Well, if you go over to our handy little GeoGebra, okay, you can press Start Graphing. And then you can click this little triangle and circle symbol to go to the geometry. So let's go ahead and make 2 points. So I'm going to click point, put one at 1, 1, and one at 5, 1. Okay, now I'm going to scroll down to lines and pick segment. So the difference between a line and a line segment is that a segment just connects 2 points, whereas a line continues infinitely. In this case, we just want a line segment. Okay, now notice here it says midpoint or center. So we can click midpoint and click on the line and it will give us our midpoint. Now we can clearly see these coordinates, but let's actually turn on their labels so we can actually see them. So we go back up to move. All right, so then we can right click and press, actually, there's a better way of doing this. You can hover over. No, you can't? Thought you could. Okay, let's go to settings. And we want to show label. We want to show name and value. Okay, and then for the same thing here, settings, we want to show just the value, the midpoint. And then finally, for this one, same thing. Settings, we want to show its name and value. So that actually shows the coordinates. So notice that if we have point A, 1, 1, and point B, 5, 1, then the midpoint is 3, 1. 3 is directly halfway between 1 and 5. So I can change B to make it go to, let's say, 10. So now notice that the midpoint is at 5.51. Okay, so 1 plus 10 is 11. 11 divided by 2 is 5.5. So the midpoint is directly halfway between the x values. Okay, now if we take a vertical line, for example, you can see that our x values are the same, but the y values are now averaged. So the average of 1 and -3 is just -1. Okay, and I could continue with example like that, stretching this as much or as little as I wanted. Okay, so obviously it's easier to see with integer values. But now what if it's not a horizontal or a vertical line? Something like this. Okay, so notice here we have the point 1, 1, and B is the point 6, 5. This point in the middle is still the midpoint of this, okay? So let's see what we have. So 1 and 6, and then the midpoint value is 3.5. Is that the average? Well, 1 plus 6 is 7. 7 divided by 2 is 3.5. So yes, it is. And then the average of 1 and 5 is 3. 1 plus 5 is 6. 6 divided by 2 is 3. So if we go back to our note, it should make sense to you that the midpoint of a line segment can be found by taking the average of the x values and the average of the y values. So in other words, if we label this as point A and we call it x1 and y1, and then we have point B, which is defined by x2, comma y2, then we can have a midpoint. Okay, so you can estimate where you think this midpoint is. Okay, and we call that capital M with a sub AB. So remember that slope is little m. So little m has like rounded humps, that's slope, and midpoint is the pointed m like that. So that's how you can tell the difference. So the midpoint of AB, the x value is you just take x1 and x2 and find the average. It's just the halfway point between the x values. And then the y value is, you just take y1 and y2, add them to, that's a 1. Add them together and divide by 2, and that's all it is. So this is just the average of the x values, and this is just the average of the y values. It looks kind of scary and confusing, but let's just remember that's all that this means, okay? In fact, it's better to just remember the concept than it is to try to, memorize the formula. Okay, so let's find the midpoint then of this line segment. So here we have A, and it is 1, 1. And this coordinate is B, and it's 5, 3. So let's do the midpoint formally. So the midpoint of AB is equal to, now we find the average of the x values. So we take 1 plus 5 and divide by 2, comma. Then we take the average of the y values. 1 plus 3, divide by 2. So this is the coordinate. So 1 plus 5 is 6, and 1 plus 3 is 4. So you get that the average is 3, comma 2. That's the midpoint. So let's graph that and make sure it looks correct. So let's go to 1, 2, 3, 1, 2. And yes, that is the midpoint. Okay, now let's do B. Okay, so first you identify the two coordinates. I like playing around with these colors. I have more options now. 1, 2. So -2, 1, 2, 3, 4. So this should be -2, 4. I apologize. The dots aren't lining up perfectly, but let's just pretend they are. And this is 4, 1. Okay, so you go ahead. If you want, you can pause the video and try this on your own. So you get -2 plus 4 over 2 and 4 plus 1 over 2. You're just finding the average. So that's 2 over 2 and 5 over 2. Okay, so 2 over 2 is 1. And then 5 over 2, you can leave it as 5 over 2. Or since it makes a perfect decimal, you can make it 2.5. So let's make sure this looks right. So 1, 2.5, yes, that does look like the midpoint of A, B, where this is A and this is B. Okay, so you don't need a diagram to do it. If you just have the coordinates, you can use your formula. Again, you're just finding the average, guys, okay? So the midpoint, in this case of JK, is take the x values, 5 plus -3 is just the same as 5 minus 3 over 2, and then average the x value, the y values. Okay, so you get 2 over 2, which is 1, and 10 over 2, which is 5. So you can do a quick visual check, which helps me. Okay, so if I think of where 5, 3 is, that's like here-ish, and -3, 7 is like here-ish, and 1, 5 is here-ish. I just do a little visual check just to make sure that I haven't put negatives or things in weird places. This just helps me feel good that I did it correctly. Okay, so pause the video, try D by yourself, then come back and check if you did it right. So the midpoint of MD is minus 4 plus 2 over 2, 5 plus 1 over 2. You get negative 1 and 3, right? Negative 4 plus 2 is negative 2, divided by 2 is negative 1, etc. So again, quick little visual. M is at negative 4, 5. D is at 2, 1. And the midpoint is at negative 1, 3. Yes, that looks right. Okay, so now, so far, hopefully you're like, man, this new unit is easy. Well, it's about to get real. I hate to break it to you. So this first page is just establishing how to find a midpoint. Now we're going to get into two special types of lines that can exist within triangles. We are focusing this chapter on geometry, coordinate geometry. So how to create triangles on the Cartesian plane when you know the coordinates of each of the vertices. Okay, so we are going to talk about something called a median. Now, we talked about medians in grade 9. A median is a special type of line that goes from a vertex to a midpoint of the opposite side. So, for example, if we label this A, B, C, our triangle, the median goes from a midpoint to the opposite vertex. Okay, so there are 3 medians in any given triangle. So you have to be aware of what specific one they want. So the first thing you want is to find the midpoint. So let's say I do. And that's just fully eyeballing it. So let's say that's the midpoint of AB. So then the median goes from that point. Oh, that did not do what I wanted it to. How does this work? That's what I want. Nope. I'll have to play around with how to do that. I'll just hand draw it. So you go from the midpoint, right? Draw it with a ruler to the opposite vertex. Okay, now just for fun, I could also show you, you could find the midpoint of BC, and then you could draw another median from A to there, okay? And you could do a third one from AC, the midpoint of AC, down to B. So every triangle has 3 medians. So we are going to actually figure out how we find the equation of a median. So go ahead, you can fill this out for now, but you're not really going to understand what it means until we go down and do the examples. So I'm actually going to skip example 2 because I want you guys to do example 2, and I'm going to go ahead and do example 3 because it's a bit more difficult. So I'm leaving the simpler one to you guys. Okay, so again, you can fill this out and we'll go through the steps. So this is what the questions are going to look like. Find the equation of the median from vertex C in the triangle with these vertices. So this can look really confusing. So you definitely want to make sure that you just graph the triangle first. That's always the first thing that you want to do. And you want to label it very, very clearly. Okay, so A is negative 3, 3. 1, 2, 3, 1, 2, 3. Okay, if you don't get your coordinates right, it will really mess things up. So label it with A and then actually mark the negative 3, 3. You'll see why that's so important in a bit. And then B is 2, negative 5. So it's way down here. So B is 2, negative 5. Okay, and C is 5, 1, 2, 3, 4, 5, 2. Okay, so we want to create, let's try this again, the triangles. So that didn't look very good, but I tried. Okay, there's one line and another line from here to here. Can I move that? Well, we'll say that's good enough. Okay. And another line from here to here. Okay. Maybe I should just hand draw them. You guys hopefully are using a ruler. All right. So what we are going to do now is draw the median. So it says find the equation of the median from vertex C. So from vertex C means that it's from C to the midpoint AB. So from vertex C means to the midpoint AB. So before I draw this median, I want to make sure I draw it correctly. So I'm going to find the midpoint of AB and label it appropriately. So that's always step one, is to find the midpoint you need to find. So the midpoint of AB, okay, so I just find the halfway point between -3 and 2 for the x value, and between 3 and -5 for the y value. So that gives me -1/2, and that's -2/2, so -1. So -1/2 and -1. So that is here, and that looks right. So that is the midpoint of AB. Okay, so my median goes from there to C. So I want to find the equation of this line. So take a look. Its y-intercept is somewhere between 0 and -1, and it has a positive slope. Okay, so let's actually get to work now. Remember, the equation of a line is y equals mx plus b. So our job is to find the slope and to find the y-intercept between these 2 points. So the step 2 is to find the slope between here and here. So we use our little m, so we find the slope between C and the midpoint of AB. So remember, that's just y2 minus y1. So 2 minus -1 divided by x2 minus x1. 5 minus -1/2. Now, you guys can just get your calculators out if you want to. But what this is 2 plus 1, so 3. And then 5 plus 1/2 is 5.5, or 11/2. Okay, so this is the same as 3 times 2/11, right? You just flip and multiply, so you get 6/11. So the slope of our line, we have that now, is 6/11. I know it's not a pretty slope, but didn't promise all slopes would be pretty, but that is correct. Now we need to find our y-intercept. So remember that to find a y-intercept of a line, if we know the slope and we know a coordinate xy, we can just sub those in and solve for the y-intercept. Okay, so we can start our equation y equals mx plus b, and we can sub in our m of 6/11, and we can also sub in the point 5, 2. So x is 5 and y is 2. So we can put 2 equals our slope, 6/11, times our x, 5, plus b. Now we just need to solve for b. So 2 equals 30/11 plus b. Okay, so b is equal to 2, or 22/11 with a common denominator, minus 30/11. So that is equal to -8/11, which is between 0 and -1, as you can see visually. So our final step is to just write the equation of our line. Y equals m is 6/11, x plus b is -8/11. And that is the equation of this median. So I told you it's not very pretty, that's why I did that one for you. So I want you now to go and do the steps for example 2. Follow these exact steps, okay? So first you want to actually graph your vertices, okay? Do it quickly, -3, -1. Okay, you should label it 3, 5, and 7, 3. Or sorry, 7, -3. Okay, so it should look like that. Then it says the median from vertex A. So because it's from vertex A, that means it's to the midpoint of BC. So it's the midpoint on the opposite side. So step 1 is find the midpoint BC. So do that. Step 2 is find the slope of BC. So the midpoint of BC. Step 2 is to find the slope, sorry, not a BC, I lied. The slope of the median. Okay, so that's from here to here. Okay, the third step is to find the y-intercept by subbing in one of the known coordinates and the slope you found in 2. And step 4 is to just write that final equation. You should get y equals 1/4 x minus 1/4. So the slope here should be 1/4. The y-intercept should be minus 1/4. And this midpoint in step 1 that you should have gotten should have been 5/1. So try that now. You can also go to GeoGebra and verify your work. So if I go back here, I can go to Start Graphing. And we can go again to this shape. Okay. So we want to go down and pick a point. So we can do -3, -1, and then 3, 5. Oops, go back to move so you can move it to see where you want to see it. Then click point again. So 3, 5, and then 7, -3. Okay, so once you've dropped all your points where you want them, you can pick the line segment tool and connect them. So A to C, and then C to B, and then B to A. Okay, so then you want to find the midpoint of BC. So you select midpoint and simply click on BC. And now you want to create a line, not a segment, but a full line between A and D. So this is the median. Okay, if you go back up and click the move, you can right click on this line, go to settings, and pick show label, name and value. And you can see that its equation is 0.25x minus 0.25 or 1/4 x minus 1/4. So hopefully you are getting comfortable with using that. Okay, so now we're going to a different type of line called a perpendicular bisector. A perpendicular bisector, or it can also be called a right bisector, is a line that passes through a midpoint, but it's perpendicular to that line segment. So it doesn't necessarily go through the vertex off the opposite side. So for example, if this is A and B and C, to draw a perpendicular bisector, you first find the midpoint of the line segment in question. And then your line, oh boy, this isn't going to be great. You should really take a ruler and do this, is perpendicular to that line segment. So it's perpendicular here. This should be at a right angle. So notice that it is a line, okay, and it doesn't necessarily go through the opposite vertex because that would be a median. It's a perpendicular bisector. Bisector means cuts in half, and obviously you know what perpendicular means. So now we need to figure out how to find the equation of this type of line. It's different than what we had before. Notice that we only know one point on the perpendicular bisector, so we aren't able to find its slope directly. What we have to do, what's a little bit tricky here, is that we have to find the slope of AB and then use the fact that it's perpendicular and use the negative reciprocal to find the slope of our perpendicular bisector. Then when we put a point in to find our y-intercept, we have to use this midpoint because the midpoint is the only point that's actually on our line. A, B, and C are actually not on our perpendicular bisector. The only one that is the midpoint. So again, you can copy this down, but it will have a lot more meaning once you see an example. So find the equation of the perpendicular bisector to the line P, so -1, 4. So P is -1, 4, and Q is 3, -2. So this is our line. So we want to create, oh, that's awful, the perpendicular bisector to that line. So first we need to know the midpoint of this line. So the midpoint of PQ is -1 plus 3 divided by 2 and 4 minus 2 divided by 2. So that is 1, 1. So does that look right? Yes, that makes sense that the midpoint is 1, 1. Okay, so now we have to envision our perpendicular bisector as going through this at a right angle. So I'm not drawing this perfectly because the y-intercept isn't actually 0. But this is our perpendicular bisector, and you should indicate that it is perpendicular there. So we need the slope of the pink line, but first we need to find the slope of the blue line, okay? And then because we only know one point on the pink line, so we can't find the slope in the traditional way. So our little m, our slope of PQ, is -2 minus 4 over 3 plus 1, which is -6 over 4, or -3 over 2. So that should make sense to you. 1, 2, 3, down 3 and over 2, down 3 and over 2. You can visually check that that slope makes sense. So now the slope of our perpendicular bisector, the slope of the perpendicular, is positive 2 over 3. So up 2 over 3. Okay, is how I should have drawn it. Didn't do a great job of drawing it freehand. All right, so let's continue with the pink. So that was step 3. So now step 4 is to find the y-intercept. So we set up our y equals mx plus b, and we know that the slope is 2/3, and we're going to use the point 1, 1, because that's the only point that we know for sure is actually on this pink line. P and Q, neither of them are actually on the line. So 1 equals 2/3 times 1 plus b. So b is equal to 1 minus 2/3. I just move it over. So b is equal to 1/3. So the y-intercept there should be 1/3. So my equation then, step 5, is to write the equation y equals 2/3 x plus 1/3. And that is the equation of the perpendicular bisector to PQ. All right, so this last question is a word problem, but essentially you're just finding the perpendicular bisector of the PQ in this scenario. So I am going to leave that for you to do on your own. The answer is y equals 4/3 x minus 3. So attempt to follow the steps that I have on the previous page, okay, right here, to actually do this. Okay, I am going to show you as well how to do it using GeoGebra. So let's take a look at that. So we'll start a new window. Okay, and we go to the algebra section, not the graphing calculator. Okay, so we have a point. So we want to construct a point at -1, 4. And at 7, -2. So in this story, these are schools. So we want to connect them with a line segment. Okay. And we want to know what the perpendicular bisector is, because any point on the perpendicular bisector will be equidistant from A and B. So it's that simple. You just have to click it and it will show up. So if I go back to my arrow here, I can right click and show settings, and I want to know the name and value. So you can see here, it says 1.33333x minus 3. So that's just the decimal version of 4/3 minus 3. So it is what I said, okay? So again, when you're doing it by hand, you graph your 2 points, A and B. You find the slope of those two. Use the negative reciprocal for your new slope. Find this midpoint. It should be 3, 1. use 3, 1 and the slope to find b, and there you have your equation. So I know it's a lot of steps, but I am confident that you guys can learn this, and we'll work on it more together in class. So thanks for watching, guys, and I hope you learned lots.